Hello. Yes. 원치. Um, yes.
You can put it on this. You don't have to put it on the big screen. We only have these, so you can have a yeah. It doesn't work if you don't, if I point it there, it doesn't work. If I point it there, it doesn't work. If I point it there, I don't know how to change. Okay, it's changed.
And it's just
So
front and
I can point anywhere and I can change.
back and forward.
Back and forward. So it doesn't matter where you point. It
Should be as long as, what happens, people stand behind and it's line of sight, and it's not behind you.
So switch it,
Goes to it.
switch it off, switch it on when you start and click it anywhere. You don't have to point it there.
Yeah, you need to point.
No,
You don't.
it works anywhere.
Okay.
Yeah. Thank you so much. You can take off the.
Yeah, he told me. Why I asked. Oh, this is what's I know. Oh, that's now. Although you don't pronounce it. Okay. Oh, yes, yes, so, yeah. It's still.
You wrote that. That was the way you wrote it.
Oh, it's the It's here,
Yeah.
because I just can't identify because I don't.
I don't think he's here, because here he will have come to meet us. I hope. Or maybe he's here, doesn't think he needs to come meet us. I think that might be him. Where? The guy on the right. The blue tie. I think that might be him.
The quick coverage.
Oh, yeah, we actually reviewed that this morning because the receiver's over there.
But then even if you pointed it, it still works.
Oh, really? So they don't
Um,
have to go.
Oh, Steve said just point it over
over
that
there.
way.
Okay.
Yeah,
Oh, which is faster or better? It makes no difference.
it makes it, as long as it works, right?
Okay.
I'm sure people will be clicking around.
Yeah, but then they know which side for forward, which side for back.
Yes, yeah.
Okay.
Good morning, everyone. Good morning, everyone. I know it's early, but yes, here we are. So I want to start off with a little joke here, and I got a rousing a response when I tested it out. So let's see how it goes. So where do data scientists go camping? Does anyone know? Where do data scientists go camping? In random forests. See, we can have fun too, right? Well, welcome to the Sustainable Data Analysis Pipeline Symposium. So my name is Lori Scott Sheldon, and I am moderating the session along with my colleague, Nofisette Oki. And so when you think about sustainability, you know, we have many definitions of sustainability, but one that's particularly relevant, or that I think it's particularly relevant, at least for data analysis pipelines, is the ability to maintain or support a process continuously over time. And this includes the data which are generated, shared, and used, the software used to manipulate, to analyze, and interpret the data, the infrastructure needed to support those data, software, the training that's needed to use the data, the software, and the infrastructure, the funding, of course, right, that's necessary to support the data, software, infrastructure, and training, and the environmental resources needed to support the computational demands of many of our artificial intelligence and machine learning models generated from these data. And finally, we need to consider how to do all of this in an ethical and responsible way. So that's a big task, right? To touch on all of those different pieces. So our speakers today will attempt to address these and many other questions about sustainability throughout their talks. And they'll probably have more questions, you know, raise more questions than answers, because we don't actually have the answers. We just know that there's a lot that needs to be done, but we're still figuring things out. And so we hope that this leads to a really robust and engaging question and answer period at the end. So without further ado, I'm going to introduce our first speaker, which is Dr. Samir Panji. And Dr. Panji is the program manager of the Alwazi Open Data Science Platform. His work focuses on the development of sustainable bioinformatics, computational infrastructures, genomics capacity, and health data science within Africa. And the title of his talk is Sustainable Data Infrastructures. So please welcome Dr. Samir Panji.
Morning, everyone. I'd just like to thank the organizers for giving me a chance to speak at the third DSI Consortium meeting a little bit about sustainable research infrastructures. So this is just a quick outline of my presentation. There we go. So I'm just going to talk about research infrastructures and importance just to set the scene. I'll talk a little bit about the components that goes into creating a data commons infrastructure. And I'll focus on data commons infrastructures because this is similar to what Iliwazi ODSP is trying to build for DSI Africa. At the heart of these infrastructures, interoperability and standards are quite important. And I think to run the tools and stuff, you also need to have replicable and reproducible compute, which speaks to the FAIR goals. Talk a little bit about the data discovery, and a little bit of how people can automate the access to data as well, and a little bit of sustainability. And I think it's the most important thing about these infrastructures is they are computational, but it takes the people to actually drive these infrastructures and build the communities. So what is a research infrastructure? Research infrastructure can be classified as any tools, facilities, or services that assist a researcher in the generation, acquisition, and processing and analysis of data. And these can be physical, such as equipment in large biomedical facilities, or it could also be remote, such as the HPC facilities that we use or computing systems. In many cases, they can also be hybrid, such as large genome sequencing facilities that tend to be co-located next to compute centers. In order to access these research infrastructures, there are three types of access. You can have it physically, where you have to be on premises with your samples and prepare them, or it could be remote, such as through authorization and authentication. Or it could also be virtual, such as your databases like GenBank, which is public access. So why they're important? Research infrastructures are important because of the 3 V's of big data. That's your volume, your velocity, and the variety of data generation that's increasing in terms of its acquisition, processing, and analysis. Also, the scientific discipline is becoming increasingly complex. We are having more and more data sets being integrated from various disciplines. A good example of that being the DSI Africa Consortium. And this leads to collaboration across disciplines and across borders, such as health and climate change. And I guess most of the data that we're generating in today's day and age is digital, and it is captured digitally. So it needs to be processed, stored, and made accessible to the community in formats that they can also consume it with. And I think research infrastructures also play a big role in helping to develop and core standards. And these also speak to the FAIR goals as well, your findable, your accessible, interoperable, and reproducible, and reusable goals. And they're important for developing the human capacity. They increase your knowledge and skills. And most important, I think they empower researcher communities to conduct science. So we have various components of a research infrastructure. And this diagram is taken from the Global Open Research Commons Working Group within the Research Data Alliance. So the couple of components, your light blue components at the bottom are actually the physical parts that a user interacts with the system, such as your interfaces, your tools, your research objects, and the tools that run on that, as well as the storage. At the heart of this is your interoperability and standards. This is quite important because without this, you cannot speak to different tools, you cannot speak to different commons, and you cannot speak to different data sets as well. And then the blocks in white is actually the governance structure, and that's the people layer that helps make the infrastructure successful. Without users, an infrastructure really does not have any use. So at the heart of this is the interoperability standards. And at Iliwazi, we are really focusing a lot on the Global Alliance for Genomic Health Standards. These are a set of open standards that have been developed by the community. And a couple of standards that are important for us are standards for discovery, such as you'll find your data sets, such as your Connect API, your data use ontology, and then also your analysis kind of platforms, such as your TERS, your WES, and your DERS as well. And all these standards enable international sharing. They promote sharing across the continuum and also promote interoperability. And the nice thing about these standards is they're open source and they're developed by the community. So there's a big community behind them and they're not closed. So one of the good standards that the JA4GH has created is the data discovery standards. It's for querying data across different data sets and different infrastructures. You have different types of interoperability. You have your technical operability, which is where files you can understand, systems can speak to each other at the technical level and understand them at files levels. You have your syntactic interoperability, where you have data formats which can speak to each other, but they don't really use the same language. Or you have your semantic interoperability, where you have your use of ontologies and your data structures are the same. The problem is within biomedical research, and I'm sure this is the same in other disciplines, is all the data tends to be in silos. So you can have them stored in different formats. You can have them in file buckets. Oops, sorry. Oops, let's go back. So you can have them in different kind of formats, such as your CSV, your relation databases, your Google Sheets. And then on that, there's something called a data connect, which is a layer that actually pulls from all the different data sets. The reason you have this data connect layer is it allows you to actually do syntactic interoperability. So all you need to do is expose your data as a JSON format and give your data model without exposing your data. And you don't need to go through all the heavy harmonization as other groups need to do. Another good example of what we're using is the data access, data use ontology. A data use ontology can be considered as a Creative Commons license for data use. This is quite useful because genomic data and biomedical data, and I'm sure a lot of the data sets in DSI Africa will have controlled access. And this controlled access has its own permissions on how one can access it and not access it. For a researcher coming in, it's very difficult to know what they can use the data for and if it's applicable for research. So this is really nice because it tells the researcher what they can do. For a data access committee, it also allows them to understand that, okay, this does fit in with the requirements of the data. And because it's an ontology, it can be automated with the matching algorithm to give you what's known as a data use oversight system, which has been developed by the Broad. In order to make your tool stacks and your workflows available to the community, we tend to recommend people using containers. Containers are just a lightweight means of repackaging your software in a user-defined software stack, and they're easy to share. The nice thing about that is it includes all your dependencies, so you don't need to keep a lot of dependencies in there, and your operating system is also encapsulated within there. They're nice because they're very portable. You can run them on your desktop, you can run them on an HPC as a Singularity containers, and you can run them on the cloud as well. So this allows us to replicate the compute environment, which can be very important, especially when you're doing data analysis, because you have really complicated software stacks. But in order to reproduce the science, you need to have a recipe. What is the recipe that you followed in your data analysis? So you have a couple of scripts, but your scripts could have different parameters, and somebody else running it on a different platform will get a different answer. So what we ask people to do is create a workflow. A workflow is just a description of the processes of your analytical pipeline, and it consists of a series of tasks. The nice thing about workflows is they're very reproducible. They allow people to run your code really easily and come up with the same results as well. And this you can share and collaborate across borders and across disciplines as well. A lot of these tools and services are cloud native, so we do put them in places called such as Dockstore. So Dockstore is just a container registry and a workflow registry. Nice thing about things like Dockstore is you can actually take these workflows and you can actually pull them on different cloud platforms, such as the Iliwazi Terra platform. So Iliwazi Terra is a cloud native platform that allows one to do a lot of analysis and collaborate at a global scale. So this is so what you have is you have your analysis tools, which are your workflows, which you pull in from Dockstore, or you can put them in yourself. You have your data types and sources, which are stored in the cloud. And then you have your analysis platform, which is a workspace where people pull in the data and they work and collaborate together. That results in your analysis and your outputs and your visualizations, and you have APIs to collect to other environments as well to pull in data. And the nice thing about this is it gives you interactive tools where one can also interact with the data and collaborate and share notebooks and RStudio code as well. So sustainability is tough, especially when you're in a research-funded environment. I think on the outset, when you design an infrastructure, you have to look at your models, you have to look at agreements, and you have to look at different funding and resourcing activities to ensure the long-term viability. But not just for the infrastructure, but also for the people that are running the infrastructure, because without the human capacity to run the infrastructure, it really does not, it doesn't work well. So in terms of sustainability, I mean, one can look at mixed streams of investment. You can look at potential cost recovery via subscriptions or service payment models. Each of these have the pros and cons, which I'm happy to go in a little bit more detail. But you can also look at time and effort contributions by communities and collaborators, such as people like the Red Hat community developing code and giving back to them. You can include plans for scale. I think including plans for scalability at the outset of your infrastructure is important, because you're only going to increase the amount of data and users you have, because a good infrastructure is actually a victim of its own success. So, and I think the main thing sustainability should factor in is the human capital, because you want to try and retain that human capital because it's an accumulated knowledge. And if you lose that knowledge, you lose the ability to effectively run that infrastructure. And I think the most important thing about infrastructures, which is not mentioned in that nice hexagon diagram I showed you, is the people and the community and the capacity it builds. You need to engage with multiple stakeholders for the research infrastructure to succeed. That's your funders, that's your users, that's your tech providers, and also you have to engage with the public as well. And I think one of the most important things I have found with infrastructures, especially in Africa, is they help build communities around specific practices. A good example would be the RedCap Africa community that's been built for data professionals. RedCap Africa has seen a series of increasing growth within Africa over the past 10 years, and that's because it's had an active community and champions behind it. Another good example of a research community is the Research Software and Systems Engineers of Africa, and this is a forum for African software and infrastructure professionals in research, which don't really tend to get recognized in the academic sphere, which is strange because I'm sure 100% of you are using software right now when you do your data analysis. And I think a good research infrastructure enables one to adopt fair principles. And as I said, most importantly, develop the human capacity, expertise, and education of the public and empower the users. Some useful links, and thank you.
Good morning, everyone. I'm Dr. Nafisat Oki, and I'm co-moderating this session with Lori. I do not have any jokes in my box, so I'm going to go straight into introducing our next speaker, Dr. Chris Jack. Dr. Jack is a climate scientist at the University of Cape Town with expertise in high-performance computing and computing platforms and dynamical and statistical modeling and analysis. His research focuses on the intersection of urban contexts and climate risks, and he's the co-PI of the HEAT Center. Today, he'll be presenting on the data analysis pipelines and his experiences at the HEAT Center. Thank you.
Great. Thank you so much for the introduction. And thank you for the previous presentation. It was a really nice background foundation for the rest of the session, I hope. I flew in late last night, so I'm a little bit sleep deprived. So anything I say cannot be held against me. Thank you. I'm also not used to, I don't like podiums. I would rather walk around the room, but I'll try and stay in one place. So thank you. I'm going to be talking about the experience of the HEAT Center and the data pipeline. Obviously, it's always hard giving this kind of presentation because there's a lot of people behind all of this. And I just want to acknowledge all the partners in the HEAT program, who are amazing partners, many of them here today. I won't mention them all by name, but I do just want to acknowledge that. And in fact, the theme through what I want to talk about today is the people behind these data pipelines and the importance of those people. So you can see all the logos on there. So the HEAT project, oh, I can see it down here as well. That's amazing. I don't have to turn my head. So the HEAT project is really focused on the impact of heat on health. It's built on an innovative, I hope, and experimental, you'll see, multidisciplinary data analysis pipeline. It's broken up into two main projects. The first one is a individual participant data meta-analysis to try and quantify the impact of heat, of high ambient temperatures on maternal and child health in Africa. The second one is focused more on urban, which is my real passion, and it's looking at innovative machine learning methods and multi-data analysis towards the development of an urban heat health early warning system for African cities. So big ambitions. These are what keep me awake at night. Anyway, so let's talk about the pipeline. And in the HEAT project, we don't actually have one pipeline. And it's another theme that I want to bring through my talk today is there's a lot of people here, but also we're trying to bring together essentially multiple pipelines. So you'll see there's a climate data pipeline at the top there. That's my area of expertise and some of my team here, Lisa's sitting in front there. We're really core to this kind of pipeline. We're also developing now an air quality data pipeline. Core to the HEAT project and the challenge within the HEAT project is the health data pipeline. So I'll spend a little bit of time on that. And then there's also a socioeconomic data pipeline. So we're trying to bring all of these pieces together. So particularly for the urban project, we want to understand heat health vulnerability in a city. We need the socioeconomic data. So essentially we have three pipelines, all very different across different disciplines, involving lots of different people and different institutions. We're trying to bring this all together into one kind of operational framework. And there's a box there, AI, ML modeling. Obviously, there's a lot in there. And what Suma spoke about earlier fits a lot in there as well. And then we have these outcomes. So we're going to have different data outcomes and different research outcomes. So if you like, this is a big picture of our pipeline landscape. But obviously, as we're thinking about developing these pipelines, we're also thinking about what is the bigger picture in which they're sitting. And I think sustainability really connects to this as well. Why are we developing these pipelines? We can spend a lot of time developing the code and developing it, the platforms and so on. And sometimes I think we lose sight of the bigger picture in which we're operating. So something we're thinking about a lot is how does this all feed back to the upstream providers, all the people producing data that we're using on all these different streams? How does it interact within the broader research landscape? Where does it fit in? Okay, so just briefly, I'm not going to go into a lot of detail here. There are posters that talk about all these. We have a health data pipeline. We're trying to do what seems to me impossible sometimes, which is bring together potentially hundreds of IPD data sets and other health data sets into one harmonized health data sets to address these two different research questions. This is a very big challenge. Obviously, there's a pre-processing step in there, which the data comes in all different formats. So I love standardization even more every day, it seems, because every data set we get comes in different formats. And it's a key challenge for sustainability. I'll show you some of the numbers in a minute, but how do we develop these pipelines in a way that is sustainable resource-wise when we continue not to comply with standards and so on? And there's often good reasons why people deviate from standards, and it needs to be a broader conversation about how these things happen. A big thing for us is obviously the metadata harmonization. How do we do this efficiently? How do we map to a common ontology, which is what we're trying to do? How do we map to a common code book? How do we standardize variables and units? And how do we do that in a way that is efficient and sustainable? So obviously not obviously, but we are looking towards AI methods for augmented mapping of data sets into controlled ontologies or standard ontologies. We're having some progress there. We're looking at AI augmented metadata extraction using large language models to try and go through study documents and identify key metadata within those. This is all a push towards making this a more efficient and hopefully sustainable process. This is a key part of the picture, which is a tool that Peter Marsh, who's here, has developed in collaboration with everybody else in the team. This is a web-based platform, thank you, that allows researchers to come in and contribute to the harmonization process, the mapping onto a controlled ontology, identification of variables, and it will push through into the harmonization process. This is now an open source tool, and we're really hoping that others will pick it up. And again, it speaks to sustainability, that we don't duplicate the development of these kind of tools, that they can have a broader impact across the community. Just some numbers. These are the numbers of studies that we're trying to process at the moment. We have 96 currently in process, many others in different stages of processing. I'm not going to go into the details. You can talk to us later, but these figures also keep me awake at night. Okay, onto the climate data, which is my main area of expertise. Climate data science has really come a long way over the last decades that I've been involved. There are really strong existing metadata standards. We have well-described ontologies, well-described controlled vocabularies of climate data. So the climate data pipeline in some ways is quite simple. I think where we're struggling is the implementation and the application of climate data. So this is a figure that Lisa produced. She's also over there. Showing the difference in temperature from averaged across the year from different data sets for a particular location. And you can see there are huge differences between the different data sets. And so often what we see is climate data is used because it's available, because it has high resolution, because it's easy to access. It's in a nice data format. Maybe you can pull it straight into your analysis. And yet often it has really large errors or biases or challenges in a particular context. So we're trying to think about how do we build these climate data pipelines that allows a researcher who doesn't have expertise in climate science to use the data appropriately to choose the right data sets. And again, this comes down to people. I'm running out of time here. So other things we're trying to do is further augment the climate data pipeline, because often when we get down to applications like heat in a city, that data just doesn't exist yet. So we're developing new approaches. The one thing we're trying to do is use machine learning combined with dynamical modeling. Dynamical modeling, climate modeling has huge resource requirements. We require huge big computers. We have a biggest computer in Cape Town, But in Europe and the United States, there's massive computers and a huge amount of energy goes into climate modeling. So there's a big push across many of the big climate centers to use AI and machine learning to basically replace a large part of the dynamical components. And a lot of that is around the energy consumption of these platforms. So we're also pursuing that. For us, thank you, I'm moving fast. It's just we don't have the computing capacity within Africa to do a lot of this, so we need to come up with innovative approaches. And then lastly, the socioeconomic data pipeline, which is a whole big world of complexity, very little standardization, very different spatial aggregations, different inconsistencies. So this is a particular challenge. IBM, who are partners on the team, have been working on how we combine these kind of data sets into cohesive indices of vulnerability and so on. But it's another big challenge, yet another disciplinary area that we're trying to bring together, different language, different jargon, different everything. Okay, so I'll end off with some reflections. So why an integrated data pipeline? I think the previous talk also mentioned the challenge of interdisciplinarity. Increasingly, we're trying to work across disciplines. We're not just working within health or climate or socioeconomics. We're trying to bring all of these together. Do we do this as one big mega pipeline? Do we try and bring pipelines together? How do we pull these different data sets together in a way that's really going to be sustainable, doesn't break when the projects end? I think that's a really key one. The climate data pipeline that we have established at UCT is really sustainable because it's not project funded. It's project funded in a very piecemeal way, some creative project funding, but it's been sustained for many, many years. And we've developed that capacity over many years, and that we've established the standards over many years. So now we leverage that in multiple projects. But this project cycling and developing platforms for particular projects is a key challenge, I think, for sustainability. Also, we don't know where we're going. We're learning as we go. So it feels like every couple of months we shift direction in the heat center as we try and adapt to what we're trying to do. We cannot plan out these data pipelines up front and then implement them. It's not a case of just passing over to software developer and please implement this. It's very circular, very iterative. And that comes back again to people. And then my last point that I'll end on is, don't pick up the 1 minute sign. The last point that I'll end on is, and maybe this is a bit provocative, but I think data pipelines should actually be equal part relational, code, and then reflection and learning. And I really want to focus on this relational. I think where we fall down is where we don't build the relationships and the partners. And those need to be really functional, trust-based relationships, especially working across disciplines, especially working across hierarchies of senior to early career researchers. We need to be building that relational capacity within the community to develop these kind of pipelines. It relies on people, relies on talking across different disciplines. We really hit that in the heat center, and I think hopefully we're moving through it by spending a lot of time talking to each other. And we need to be building that capacity. So as we're building capacity to run machine learning code and build new AI methods, we also need to be building capacity in the early career researchers to interact across disciplines, to work with each other. And then reflection and learning, I think, is really key. Are we looking back and saying what has worked, where we failed, what mistakes have we made, and where can we learn from that? I think the code is the easy part often. Thank you very much.
That was excellent. I really like the focus on the, building communities, the relational aspect. I think that's something that we can all really think, take away from this talk. So our next speaker is Dr. Celestino Ubua, who is a professor of pharmacology and therapeutics at Barara University of Science and Technology, or MUST. His work focuses on building capacity for research in HIV and non-communicable diseases. Dr. Ubua is the PI of the MUST Data Science Research Hub and will be presenting on achievable, sustainable data pipeline in Africa. What will it take? So please welcome Dr. Ubua.
Thank you so much, Roddy, for the wonderful introduction. Okay, So the previous two presentations actually have set the basis of my presentation, and it makes it a lot easier for me to communicate the issue of sustainability. And when I talk about Africa, we need to realize that Africa is not one continent. Africa is 3 continents. There's North Africa, Sub-Saharan Africa, and South Africa, not Southern Africa, but South Africa. And you can explore that. So my talk is going to be largely around sustainability of health data pipeline in Africa. The designers or the framers of the DSI Africa are focused on 2 things: data science technologies and improved health. So whatever else is in between, we're trying to use data science technologies to improve health. But we need to note that Africa has lots of exploitable resources. We have land that can be exploited. We have human beings that can be exploited. And in the past, we had slave trade, but now we have brain drain as a form of exploiting human beings. Minerals are being exploited. And now the biggest exploitable resource in Africa is data. Of course, if I paraphrase what John Nesbitt said with respect to America, I would say that Africa is drowning in data, but starved for knowledge. In America, at that time in 1982, Nesbitt said that there was a lot of information in the US, but they didn't know what to do with the information. And I think we are in that, at that point in Africa. The second thing is that data in Africa has been collected through routine practice or research. And Africa definitely has accumulated a huge ensemble of health data. Unfortunately, this health data is dominated by data scientists or computer scientists, with the practitioners or clinicians having almost minimal or no role to play in it. And most of the data is not readily accessible nor analyzable for reasons that, one, the manner in which the data is collected is not very clear at some points. The pipeline is not very clear. And of course, the deficiency or lack of appropriate technology for processing and analyzing this data. If you see what my previous presenters have put out there, most of us in this audience probably could not follow the map that was put in there, simply because of the complexity of what is needed. There's need to appreciate the infrastructure needs in Africa, and particularly the prioritization of data pipeline in Africa. One is that there is completeness of data and including metadata, which is not very clear at the moment. There are also complexities, and of course, the previous presenter talked about complexities around integration, storage, ownership, and sharing of data, particularly now that we are advocating for open access to data. Africa will still need issues to do with career development pathways, not only for the data scientists, but also for the users and implementers of the data that is going to be analyzed. So what does Africa need? So I have a schema which kind of outlines critical areas of intervention. Acquisition of data, I would say, is happening in all kinds of forms, but the storage, where the data is stored, the capacity for storage, is it going to be local storage or cloud storage or other forms of storage? Processing of data, can it be done locally, where it is stored? And of course, analysis, where is analysis going to be done? So those are 3 areas that require critical intervention. In terms of technology, we need support. Africa needs some technological support to overcome the challenges of data analysis pipelines. Funding equity. And our funder, NIH, is here. And yesterday, you saw the data regarding NIH funding in Africa. However, there are challenges, there are some discrepancies in the funding. We think that in order to support sustainability, there is probably need to relook the issue of indirect cost. Because when you look at the ratio, the rate at which indirect cost is awarded to lower middle income countries and to our colleagues in the north and western part of the world, there's a huge discrepancy in that. And that limits the sustainability in terms of the kind of support that needs to be done. Collaboration, of course, in terms of data pipeline development is needed, particularly how data is going to be sourced, stored, analyzed, and so on. There's a saying in Africa that there's need for you to skin the animal where you've hunted it. Where you've killed it, you skin it from there. So we hope data is going to be stored, analyzed in Africa. For sustainability of data pipeline, I want to borrow the schema that was drawn by Provost Ben and his colleagues, where we're talking about sustainability and realizing that there are three main pillars or dimensions that support sustainability: economic, human, and environmental. In these require some form of integration, integrating economic, human, as well as the environmental goals in policies and activities that will carry around. This is premised on equitable opportunity that needs to exist in order and a sustainable community. We are looking at data scientists, health practitioners, and researchers in general, and also a permissive environment, particularly the technologies that are required, the policies, the laws, and the ethical issues that surround data access and use. All these are necessary for sustainability of data. There are some enablers of sustainable data pipeline in Africa. We need infrastructure, stability, and scalability. Of course, issues of power, internet, and so on are critical in our setup. Building capacity for infrastructure management, we need to develop the skills of people. We need to train and build capacity for technical staff, as well as for clinicians. And then we need to advocate for resources that support mechanisms that needs to be put in place to address these challenges. Of course, human resource recruitment and retention is critical, where we want to avoid leakages of the trained humans within our setup and being offered more. So in terms of quickly on where is our project, Barra University Data Science Research Hub. So we have designed pipelines for medical imaging, data processing, storage, and analysis. Some of the key milestones that we've achieved are education and integration. We have also achieved, we are actually collecting data now and being able to store this data. The data we're collecting includes the images and the metadata that are supposed to come with it. We have established some form of infrastructure, in our system. There's hardware, and network system that we have tried to put in place. We are improving on the quality of data. Soon after this meeting, we are going to, after this symposium, we will head back and begin the process of data labeling. And of course, we are currently also carrying out scalability of the resources that we need. This is just a schema of what we designed for data processing, which is not very different from the schema that you have seen. We have data source, we have ingestion of the data, we have the sources for storage. We are beginning the process of processing, de-identifying data, labeling, and so on, validation, cleaning, normalizing, transforming the data, and then of course, setting up the data for compute. Now, in conclusion, if I've said anything at all, just remember the three things. One is that in achieving sustainable data pipeline in Africa, we will need human capacity development, training, and involving the clinicians, scientists, and researchers together. Equitable technology is crucial, and equitable funding, which includes infrastructure development. I like to acknowledge the funding that we get from NIH. Our scientific officers, who I must say have been very active in our meetings, the Scientific Advisory Board, my co-MPIs, Dr. Jessica Evera is seated there, and you have for people to see you, and of course, other investigators and partners, and thank you.
Okay, moving along. Thank you very much, Dr. Obua. And our next speaker is Dr. Kimanthri Moodley. She's a researcher for ethical data. She's presenting on the project Research for Ethical Data Science in Southern Africa, REDSA project. Dr. Moodley is a distinguished professor, family physician, and bioethicist who has the Division of Medical Ethics and Law in the Department of Medicine at Stellenbosch University. She has expertise in medical ethics, clinical research, and research ethics. And she has considerable experience in the field of HIV prevention research ethics. Dr. Moodley is the PI, like I said, of the REDSA project, and the title of my talk today is A Tragedy of the Commons, the Ethics of Responsibility in Big Data.
So thank you very much to the NIH, the Coordinating Center at UCT, for the DSI Africa program, for the invitation to speak. And thank you also to my previous speakers for setting the scene for an important conversation in sustainability. I think this is probably going to be one of the most important sessions and conversations we need to have as we all participate in this wonderful DSI Africa Consortium. And I think we will soon be able to establish why this is so important. Now, last year I presented on the AI of ethics, and I said then that data is the oxygen on which AI depends. Now, we know that AI is used ubiquitously across the board in all sectors, in all disciplines, including healthcare. Large language models are used widely by medical professionals, but also within clinical and hospital settings. It's also used in education, in industry, and in almost every sector that we can think of. So generative AI has really become a very important part of all our lives. What is interesting is that when we train a large language model, the energy consumption is equivalent to 125 round-trip flights between New York and Beijing. So the energy consumption of all this wonderful generative AI and the massive amounts of data that go into it are incredibly important. This year, I'm going to say water is the oxygen on which data depends. Now, why do I say this? We know there have been numerous reports relating to the huge amounts of water that is being used by data centers to cool, especially generative AI service, but also in other respects of data collection, storage, and processing. Now, data centers use water in a number of different ways, both indirectly to generate electricity required for data storage, but also directly for cooling and to maintain temperatures within data centers. Many of you here know more about the technical issues than I do. It has been estimated that for a medium-sized data center operating around 15 megawatts, the energy consumption is equal to that of 3 average hospitals. We also know that where Microsoft is concerned, one of the big 5, many of you are here in Africa, probably to see the big 5, but the tech big 5 are Google, Apple, Facebook, Amazon, and Microsoft. And these companies have come under scrutiny recently relating to their water consumption. We know that the global water consumption of Microsoft increased by 34% from 2021 to 2022. This amounts to the equivalent of 2,500 Olympic pool size volumes of water. So clearly, a huge amount of water that is being consumed. Some of you may be familiar with many infographics showing how water consumption has increased across various tech companies and many of the big 5 as well. A number of publications are emerging around data center water consumption. So these are clearly important issues to consider. Now, where data is concerned, the sustainability issue occurs at various levels. We have to look at data itself as a limited and important resource, but also look at the impact that data could have on the environment. And so a further round at which we need to look at sustainability. We're all familiar with the 6 V's associated with big data, but what is clear is that commercialization and commodification of data is driving more faster, more voluminous, more indiscriminate, and perhaps unnecessary data collection, all of which is energy depleting. We know that some legislation refers to minimization of collection of personal data, but it does not occur in terms of legislation relating to collection of all types of data collection. So clearly, big data is a communal resource. People have referred to it as the digital commons. And so in order to conserve our resource of big data, sharing is an important factor. However, there are many inhibitors and facilitators where sharing is concerned. So on behalf of the REDSA project, I'd like to briefly discuss some of our empirical work and invite you to look at the posters which discuss these projects in more detail. Here we explored perspectives on data access, sharing, and protection in sub-Saharan Africa, both via a quantitative survey involving 34 sub-Saharan African countries, from which we received 140 responses from research ethics committee members and scientists and researchers. We also conducted research on scientists, and in 43 sub-Saharan African countries obtained 160 responses, all of which is published in our special issue on in the South African Journal of Science. In addition, we have conducted 72 in-depth interviews, some of which is published on the posters on display. What was very interesting, and this is just a summary, is that data scientists, researchers in sub-Saharan African countries surveyed expressed a fear of sharing data due to a number of perceived risks, including scooping of data, exploitation, commercialization, and lack of benefit sharing. There is also the academic pressure to publish, and much of the fear is fueled by suboptimal governance, ethics, and legal concerns. Now, my title is The Tragedy of the Commons, and this is a very interesting metaphoric label for a concept that is familiar in economics and ecology, but also in ethics. And this is a situation where individuals with access to public resources, which is also referred to as a common, often act in their own interest and end up depleting the resource. So the short-term interests of individuals is poised against the long-term welfare of society. The term was coined in 1833 by William Forster Lloyd, but used only in 1968 by Garrett Hardin. And he published an interesting article in Science, one of the most highly cited scientific articles with more than 55,000 citations. And in it, various aspects of the tragedy of the commons are explained. Now, common examples of this phenomenon refer to coffee consumption. And we know that drinking a simple cup of coffee on an individual basis collectively contributes to depletion of our coffee resources, with about 60% of our species under threat. Likewise, the phenomenon of overfishing, where a number of marine species are becoming extinct, and hence the concept of sustainable fishing has become important. But this concept of tragedy of the commons also applies to the threat to the environment and the use of limited resources. So clearly, we need to start thinking about a move from individual good to the common good, and from autonomy to solidarity. Elinor Ostrom was the first woman to win the Nobel Prize for Economics in 2009, And she's written extensively on the importance of the commons, on looking at natural and cultural resources that are accessible to all members of society, including a digital commons. And this is what we need to be thinking about more clearly as we proceed in all our work of big data collection. Also of interest is the Nguni word Ubuntu, which is widely known in sub-Saharan Africa in various different forms. And I'm not going to read out all these slides, but to focus on Ubuntu as a binding morality. It infuses humans with a consciousness of wholeness and interdependence on each other, but also their natural surroundings, recognizing a spiritual level of being. It's a form of guardianship of nature, and it exists on behalf of former generations and future generations, which comes close to rights of nature. These concepts of embeddedness, of science, of humans, with the environment and future generations is widely written about. It is also covered in the Ethics of Responsibility proposed by Hans Jonas and written about extensively, where we need to consider the impact of responsibility, especially in the technological age. And I think this particular ethics approach is extremely relevant as we proceed with our conversations on data science. We've spoken previously about the importance of ethical debt and technical debt, and we know about regulation for AI. The WHO has specifically stressed sustainable and responsible AI, and I'm sure you are familiar with the EU AI Act similarly, which stresses the importance of being environmentally friendly. Where tech services are used in Africa, this is an interesting piece in the conversation where French companies are using low-paid workers in Madagascar for data purposes. So how can we remedy the situation? There are many. Cloud vendors using seawater in data centers, submerged data centers, which Microsoft is doing in Scotland, colder climates for data centers, corporate environmental reports, guidelines, and legislation. But I'm sure we'll have much more time for conversation around these issues. I thank you for your attention, and we look forward to more conversation in the Q&A session.
Thank you so much, Mantri. That was wonderful. Our next presenter is Dr. Celestine Touzier. I don't know. Oh, there you are. Wonderful. So Dr. Touzier is an associate professor of engineering and biomedical electronics, electromagnetism, and telecommunication at the University of Rwanda. His work includes, among others, strengthening research capacity and expertise in digital health, digitizing the hospital patient trajectory, and secondary use of EHRs in Rwanda, and electronic mental health care architecture as an innovative solution to conventional treatment in Rwanda. Dr. Touzier is the MPI of the Research Training Program in Data Science for Health in Rwanda, and is the faculty of the recently funded Synthetic Data Healthcare Data Platforms for Data Science Training, or the Synapse project. So please welcome Dr. Touzier, who will speak on the research training programs in data science for healthcare in Rwanda, best practices in data sharing.
Good morning, everyone. Thank you for the introduction. And I want to present the research training program in data science for health in Rwanda, the best practices in data sharing. And this is DST Hirgwa, data science training. Hirgwa means to be happy. And I hope that you are happy in Kigali and you are enjoying the life in Kigali. So this is a partnership between Washington University in St. Louis, University of Rwanda, and EMS. EMS being Africa Institute for Mathematical Sciences in Rwanda, where we have the MPIs, David, myself, Celeste, Wilfred, Philip, Pacific, and Victor, and supporting colleagues, Sam, Isambi, Michael, Andrea, Dan, and Kati. So the research training program objectives. The first one is to develop and refine competencies and model curriculum in data science for health, as this is a research training program. And the major scientific areas include computer science and informatics, statistics and mathematics, and biomedical sciences and public health. The second objective is to recruit and expand a diverse group of well-trained data science for health trainees at master's, PhD, postdoc, and junior faculty. The third objective is to develop a robust training program with a focus on didactic, research proposal development, career advice, and mentoring. The fourth one is to evaluate the training program by trainees and by program faculty. And the fifth one is the program transfer and long-term sustainability. This will be the full program will be transitioning in terms of administration and leadership from Washington University to University of Rwanda. And as we are talking about best practices in data sharing. So this is in terms also of mentorship, and thanks to this DSI Africa funded by NIH, where this collaborative ways to go is really enhancing, and this is the discussion we're having, is enhancing also African researchers in order to mature and at a certain point, this will lead to the sustainability of the project. So far, what we have achieved, the first is the development of data science for health curriculum and recruitment of trainees at master's, PhD, and postdoc. And the third one, the identification of data set and the research project for trainees. Fourth, the identification of research proposal in progress now. We have already organized a boot camp in terms of grant and manuscript writing, skills, career advice, research and training. And the first one was delivered online. The small research project for preparation, completion, and the submission. We are having monthly meetings with trainees. They present their proposal for a research project. And the best practice is that the trainees, masters, PhD, and postdoc, we are having this monthly meeting with their mentors, and juniors are learning from seniors, and this is another way of sustainability. The website is being developed for WashU, UR, and EMS, and we are holding the bi-weekly project management and leadership meeting. Those are our trainees, master's trainees, where they are working on health issues in Rwanda, in terms of follow-up on HIV care continuum, high-risk pregnancies in Rwanda, mental health, contribution factor to type 2 diabetes, and image analysis for cervical cancer, those at master's level, and the PhD, the same with postdoc. Now, as we are having those trainees at master's level, where to find data and how to use the data. And this is how we have come up with this synthetic health care data platform for data science training. And this is an additional fund to the research training program, the Synapse UE5. With the objectives to develop and refine competencies in the use of synthetic healthcare data, deliver a mentored, hands-on, immersive, semester-long research project experience using synthetic healthcare data, and evaluate the short-term training program and semester-long research project with an exploratory objective to determine the dissemination and long-term sustainability for Rwanda synthetic health data. So we are talking about Rwanda, but as I will be presenting in the next slide, those who are in need or want to know more about the synthetic healthcare data in Rwanda, you are welcome, and we are available for discussion. Yeah, we are talking about data, and the previous speaker was saying that data is now oxygen. And I think we agree, and I appreciate the idea that data is now becoming the oxygen, and but this oxygen is supposed to be available for all. This is why we are proposing to democratize the democracy to access the computational derived synthetic data, where first you identify the cohort, you select the feature, you have the synthesis and the summary analysis, and then you can export your synthetic data. When you are working with synthetic data derivative, the good things that you are maintaining the statistical properties of the original data and do not correspond one-to-one with the original patient. So, and this is solving the issue of securing the ethical clearance. And we know that talking about Africa, sometimes it become difficult to secure the ethical clearance. So this is a workshop we had on November 5th. Along this third DSI Africa Consortium, and hope that those who are there enjoyed the workshop, and we are available to continue the discussion. Now, the major objective today, we want to discuss on the use of synthetic data with within DSI Africa Consortium. We are collaborating in this Synapse project with the coordinating center. We are also inviting the training site and the DSI Africa Law and other interested in order to use the synthetic data for training and or research. This is the biomedical informatics and the data science bootcamp curriculum, and those also are interested can ask more information. Those are challenges, success, and lesson learned. The lesson learned are that we are meeting frequently. We're maintaining the open communication at all time. We have set up the communication processes and the governance structure and the shared leadership. Thank you.
Thank you, Celestine. Last but not least. Hello? Okay. Thank you, Celestine. Last but not least, we have our keynote speaker who is going to help us tie this all together. Our keynote is Dr. Lukman Lawal. Dr. Lawal is an accomplished physician, researcher, and strategist with expertise in healthcare, global health, and business development. He is passionate about driving transformative solutions for data-driven advancements. Dr. Lawal is at the forefront of the global healthcare revolution, leading the global expansion of the Mayo Clinic platform. And he's the embodiment of the harmonization between age-old healthcare practices and groundbreaking technology evolution. The title of his talk is Transforming Healthcare Through Data Science, a Vision for LMIC's Sustainable Future. Please welcome Dr. Lawal.
Thank you so much for the very kind introduction. And as you rightly mentioned, my name is Lukman Lawal. And the way I kind of explain to my Caucasian friends is look at a man. I think it's quite easy and it's easy to remember. So, but before I start today, I'd like to thank other presenters. It's been phenomenal and it's quite tough to be the last presenter. But what I would do is I'll ask everyone to rise up so that we can kind of wake up from the early morning. So I have a dance. I call it the coconut dance. I'm sure we all are aware of that. So the coconut dance goes this way. We start with a C, O, C, O, N, U, T. Another one, C, O, C, O, N, U, T. Yeah, you can all see them. That's a license to kind of forgo your gym for today. I think you've tried. Yeah. So like the introducer said, I'll be speaking on transforming healthcare through data science, a vision for LMICs. But before I start, I have a quick question. Who knows the name of this tree? By the raise of hand, I have a gift for the person. You stand up and you tell us. Yes, please. Thank you. I have something for you. A gift for you to keep everybody happy. Yes, it's the baobab tree. And my presentation today will be around the baobab tree. My presentation is kind of woven into what I call the tree of renaissance for healthcare in Africa. And I have a very short plea. Take as many pictures as possible because I need to convince my family that I'm here to work and not to party or to go on the safari. So I'll take those pictures from you. So like I said, the baobab tree. As you can see on the slide, we have the local communities gathered under the tree, understanding its significance and working towards its preservation. Take the baobab tree as more like a metaphor, as a tree that heals Africa, as the tree that needs to be nurtured, as the tree that needs to be taken care of for us to get the right kind of healthcare outcomes for the most vulnerable in Africa. But there are these beacons on which my presentation is based today. There are 5 of them. How do we ensure we have local empowerment? How do we ensure we can drive ethical innovation? How do we bring about collaborative ecosystems? And how do we make education the foundation of trying to achieve sustainable data science to drive health outcomes for the most vulnerable in Africa? And how do we become proud and be able to achieve what I call from Africa to the world? I come from some rural parts of Nigeria, Kwara State. How do we get to a point where a young, smart kid from the rural part of Kwara State, Nigeria, is able to leverage data science to provide the best of solutions, technology, and knowledge that can be sold in Berlin or Geneva or in London? I think once we start getting to that level,
then we can all be proud and be able to go back to bed at night, happy that we're part of the solution, helping truly to shape and transform healthcare in the world, leveraging data science. And as we all know, DIS Africa is beyond just a transformative organization. Their commitment to really bring people together is extremely important for us to be able to achieve what we need to achieve. And the goal is, how do we ensure we can harness homegrown talent and resources for self-sustaining innovation? How do we ensure we can advance with a moral compass? Previous presenters have talked about the ethical needs of the use of data science. How do we ensure integrity, fairness, and respect in how we use our data to advance health outcomes for the most vulnerable populations across the world? How do we build this collaborative ecosystem, building bridges, not walls? And I have a plea to the House as well. How do we get to a point, either through the AU, whereby we don't operate our data in silos, from Cape Town to Cairo, from Djibouti in the east to Dakar in the west? How do we ensure healthcare data can be shared in a way that preserves the privacy of the patients, but it can be utilized, for example, insights from Lagos, helping improve maternal health in Mombasa in Kenya, insight from Cape Town, helping improve maternal health in Cairo? I think until we get to that level, that's when we can define that as success, that we all have achieved success that is required to move Africa to where it needs to be. Then the importance of education as a foundation can never be overemphasized. We need to invest in the African mind and make it the powerhouse of our transformative journey. And like I said earlier, how do we take Africa to the world in the good sense of it? Leveraging the uniqueness and the diversity of this beautiful continent in a way that it becomes the pride of our planet. And I'm very sure the beautiful minds in this room will be able to get us to where we need to get to. More importantly, I need to re-emphasize the importance of DIS Africa in this journey. Going back to the metaphor of the tree, they are the guardians. They are going to be playing a pivotal role, which they're already playing, in nurturing this tree, ensuring that it continues to flourish and provide for the entire continent. And the vision, which we all know and we all agree, vision has to do with where are we going, why should we go there, what is winning. And the vision for DIS Africa, as I've clearly crafted here, is how do we get to a place where we have a healthy Africa that is powered by data-driven, localized solutions. And the mission is, how do we want to achieve that? How do we want to get to the vision? And for DIS Africa, it is through the integration of data science and healthcare, fostering innovation that addresses Africa's unique challenges. And I don't think I need to read through the key objectives. I think capacity building, collaboration, ethical standards, which has kind of ran through the theme of all the presenters today, and we're going to still keep re-echoing it like a broken record. So I'll take a pause here. I'll spend some time on this slide and really going back to my analogy of the baobab tree. How do we help this tree to grow? For this tree to grow, we need to understand the landscape on which this tree needs to grow. I've been talking about LMICs, LMICs, LMICs. LMICs in this context just simply refers to low and middle income countries. For some of us that are extremely interested in economics, we talk about GDPs, we talk about GNIs. And in this context, gross national income, the slight way is different from GDP that we all used to is they also put into consideration some of the earnings of foreigners of a particular country. They put into consideration the remittances, the earnings from investments, and it's somehow a better representation of the economic status of the country. And if a country has any GNI per capita less than $12,696. They all fall under the low and middle income country category. One of our colleagues, a presenter that kind of classified Africa in the context of 3 continents. Unfortunately, from this my vantage point, I think it's just a single continent. There's no single country on this our beloved continent that falls under high income country. Unfortunately, all the, I think 54 countries, we all fall under low and middle income countries. And what does that tell us in terms of the landscape? It lets us understand the kind of challenges that comes with being a low or middle income country. And until we understand the challenges, that is when we start understanding the potential solutions and how data, AI, machine learning could be utilized to help solve some of these challenges. And some of these challenges I've identified are kind of 5 in number, and they all fall under the World Health Organization health systems building blocks. At least 4 of the health systems building blocks are represented here. If you look at the limited medical facilities and healthcare professionals, which kind of brings about inadequate healthcare access, how do we start thinking leveraging data, machine learning, AI to help solve such problems? We may be able to deploy telemedicine, AI-driven diagnostic systems, and leveraging data science to optimize resource allocation. So this very first one falls under the WHO service delivery component of the building blocks. And we all know this is a challenge across the length and breadth of the African continent. When we look at poor tracking mechanisms for epidemic outbreaks, this also falls under the health information systems of the WHO building blocks. This presents with disease surveillance gaps, and leveraging data modeling and machine learning could help with predictive analytics that can provide early warning systems. Thirdly, we have unpredictable and inefficient medical supply distribution. This leads to inefficient supply chains, and we can also leverage AI and data science to help improve this delivery system. Very importantly, insufficient specialists, knowledge and training opportunities for our specialists on the continent. We all know, many of us who are clinicians, we all grapple with workforce limitations in our hospitals and clinics. Could we leverage machine learning-based educational systems and platforms? Could we also use some supportive tools that can enhance healthcare work expertise as well as decision-making? I'm sure there's a ton of those currently in the market. How do we identify the ones that are uniquely positioned to help us in Africa? Last but not the least, we have issues with disparate and uncoordinated health information system, and this leads to fragmented healthcare systems. Can we develop integrated data platforms, like I said, from Cairo to Cape Town, where we are not working in silos, where we have a system somewhere rural part of the continent can leverage solutions that are being made in Cape Town to help improve health outcomes for our most vulnerable population? Next, still staying on my analogy of the baobab tree, there's a need to cultivate the soil for the growth of this tree of healthcare renaissance across Africa. And a very popular British mathematician spoke, and I think this quote was in 2006, that data is the new oil, data is oxygen, data is water. All this lets us understand the importance of data. And according to the mathematician, he said, this oil needs to be found, it needs to be refined before it can be used for the myriad of applications, especially in healthcare that we're talking about. And that takes us through the importance of data collection, the importance of data cleaning, the importance of data integration, and the importance of data analysis across the spectrum before it becomes usable as insights that can be leveraged across the continent. Also, on my baobab tree, for a tree to thrive, it needs nurturing. And it must be sustainable. And this is what this presentation is based upon. And I've carved out what I call the case for sustainability. The importance of consistency, the importance of adaptability, the importance of scalability, and the importance of efficiency on how we use data to drive healthcare outcomes for the most vulnerable of our populations here on the continent. Consistency has to do with, can we get to a place where what we do is predictable, reliable healthcare insights from our data? Can we get to a point where we can ensure data systems evolve with changing healthcare dynamics on the continent? Can we grow the increasing data needs of healthcare systems across the continent? And can we maximize the value derived from every byte of data? We've talked about, we have a ton of data, but are we making informed insights from this to help improve health outcomes? This also helps as a slide to communicate the importance of the need to have a deep root with regards to our baobab tree and broad branches that can help improve what we're trying to do with data across Africa. The importance of resource allocation as part of the use of data can never be overemphasized. We can also leverage data to improve personalization of treatment, predictive analytics, as well as the use of telemedicine. But what's the vision for LMICs? We've talked about the landscape. We've talked about what we can use it for. Where do we see ourselves sometime in the future? What is the future we strive for? And as we all sit in this room, and going back to my baobab tree, I think I love the tree a lot. A thriving ecosystem where every individual can benefit from the healing powers of this tree. And how do we get there? Can we get to a point where we have the classical definition of healthcare accessibility, empowered local communities, proactive health management, as well as knowledge sharing? And I'll dwell a little bit on each of these items. Can we ensure every individual on the continent, irrespective of age, gender, race, religion, or ethnicity, or their income status, have access to what I call personalized, predictive, quality healthcare? That's the vision. Can we ensure grassroots initiatives drive our local data insights, something that is unique for Africa? Can we all agree there's a need to shift from reactive to predictive healthcare? And can we all agree that we need to build a collaborative healthcare ecosystem across Africa in this context? And we all need to agree, how do we advocate to the AUs and the policymakers in a way that we bring down the silos, we break the barriers, and ensure more collaborative efforts across the continent? Going back to my baobab tree, can we learn from those that have this tree and is already, so that we don't have to reinvent the wheel? And that's how Mayo Clinic comes up. I'm sure how many of us know about Mayo Clinic? I'm excited about that because we like to pride ourselves as the #1 health systems globally. I'm sure maybe Cleveland Clinic or other competitors may not like that, but I have the stage today and I can say that. So we all know Mayo Clinic is a world leader in patient care, good with research and education as well. And now we have the Mayo Clinic platform, which is open to revolutionize healthcare in the true sense of it. And the vision for Mayo Clinic platform is to create a healthier world where personalized, predictive, and innovative to all. And hopefully this could be done through data-driven excellence that's for collaborations as well as empowerment through knowledge. There's a we can learn from this as a continent, and there's a lot of collaborations that can take place so that we don't have to reinvent the wheel. I'll spend some time on this slide as well. Through the Mayo Clinic platform, this is how we're thinking about where healthcare needs to be by 2030. We can all agree in this room, especially on this continent, healthcare is very reactive. You have a headache, you go to the hospital. But can we make it more preemptive? Can we make it more predictive? Not about until you have the symptoms, but based on leveraging AI, machine learning with all our Apple Watches? Could there be a way you could transfer your EKG readings or ECG, as we call it on the continent, through the Mayo Clinic platform or whatever platform we leverage to your cardiologist so that any irregular patterns are identified and you are invited to the emergency room before you have a heart attack? That is what we're thinking about. You don't want to wait till you have the heart attack or the cerebrovascular accident before you go to the hospitals. How do we leverage AI, machine learning, and all other resources we have, make it more preemptive? We can all, currently healthcare is very symptom-based, but we want to move it to being molecular-based. Healthcare is currently corrective. Could it be curative? Very invasive. Can we make it minimal invasive? We all know, especially the continent, it's until late stage, and that's why a lot of deaths on the continent. Can we make it more early stage? Very expensive. How do we drive it to become affordable? Very personalized. It needs to be personalized. It's always in person. You have to go to the hospital, but everybody's seeking for convenience. Can we make healthcare more accessible anywhere you are? This is how we are thinking about healthcare at Mayo Clinic and Mayo Clinic platform, to be very specific. And I'm sure there's a lot of learning that we can, as Africans, benefit from as we start to leverage data to advance health outcomes. Now to explain a little bit more about what Mayo Clinic platform does. This is just an architecture to describe the way Mayo Clinic platform operates. And I'm sure many of us are very familiar with a traditional pipeline business. Many of us, whether we know it or not, have used a platform business before. How many of us have used Uber, Airbnb, Lyft, even Facebook, Amazon? I'm sure more than half of the people in this room have done that. These are typical examples of platform business. And I like to use Uber as an example. What does Uber need to do as a business? There are two key things. They need to provide the technology architecture, as well as to serve as the market intermediator, meaning they have two sides to their platform, the rider and the driver. Our role is provide the market intermediation, as well as the technology architecture that connects the platform. And this now leads to what we call network effects. The more drivers you have, the more likely you have more riders signing up. The more riders you have more drivers signing up. And this kind of continues to blossom. That is similar to the model of the Mayo Clinic platform. But instead of having two sides, we have three sides. So instead of the rider and the driver side of the Uber, we have what we call the solution developer side, data network partner side, and the healthcare providers or the solution user side. And like I said, as a platform business, as opposed to a pipeline business, you have two key roles. And these two key roles are ensuring there's a technology platform and ensuring you serve as the market intermediator that governs the platform. And that is exactly what we do at Mayo Clinic platform. Solution developers, data network partners, healthcare providers. Who are solution developers? People that leverage AI, machine learning, and data to provide insights and products and services for healthcare. Startup companies, big tech companies, pharma companies, medical device companies are all solution developers that subscribe through some fees to work on our platform. And who are data network partners? These hospitals and clinics in the world, including data from Mayo Clinic platform that is brought together, de-identified, and put into a federal system where the solution developers could come into our and validate their AI machine learning models and be able to come out with their product. Then the solution users or the healthcare providers are hospitals, clinics, government agencies that buy products and services on the platform. And like I said, the vision of the Mayo Clinic platform is to create a healthier world where personalized, predictive, and innovative healthcare is accessible to all in capital letters. And I hope with this, we can really be able to identify potential partners that we can really be able to share some of what has been working well with the Mayo Clinic platform and be able to ensure it can be domesticated on the African continent as well. So that's just simply the architect. We have solution developers, the data network partners, and the output providers working together on the Mayo platform. What are the things that can be learned from the Mayo Clinic model? There are about 4 key things I've highlighted on the screen: digital transformation, research innovation, training and education, as well as patient-centric approach. All this could be what can be learned as a continent, leveraging what Mayo Clinic has done well over 150 years. What is the path forward towards a better healthcare, leveraging data science? Partnerships, shared resources, tailored solutions, and ensuring there's a feedback loop where there's constant communication and feedback for iterative improvement. So that I don't continue to bore you, what do I hope? That when I go back to bed, I'll be excited that, yes, I came to Kigali, not to party, not to just do the safaris, but I was able to share about 3 key takeaways. We all can agree in this room that it's imperative that the need for sustainable data analysis in low and middle income countries for healthcare is now. I mean, time t equals 0 is now. We have no longer enough time to waste, but we need to start now and start thinking of how do we transform healthcare, leveraging data science, using the model that's been created by DSI Africa and many other organizations like Mayo Clinic. We can agree well that the potential is enormous. With data science, we can revolutionize healthcare in ways previously unimaginable. Everyone, let's collaborate, let's innovate, and let's invest in data-driven healthcare future for this. I guess with this, I've been able to first share the landscape of LMICs, the challenges that are unique to LMICs, the vision for a sustainable way to leverage data to improve health outcomes, previous models that has worked that we can always collaborate and share with, and some key takeaways. And I call us to embark on a shared journey with a vision of a future where LMICs have robust, sustainable, and data-driven healthcare systems. Could we get inspired by some of the good work Mayo Clinic platform is doing and what Mayo Clinic has done? Can we learn, potentially collaborate from world leaders, not only Mayo Clinic, but many other organizations from across the world? What are our roles as clinicians, as policymakers, as people that work in the payer sector or the provider sector, and data scientists? We all have our roles cut out for us. And what are the potential next steps? We need to engage, we need to collaborate, we need to innovate. And like I said, time T is now, and the journey begins now. Thank you so much for listening. And I look forward to answering questions during the question and answer session.
Thank you very much. Thank you very much, Dr. Lukman. Please give a round of applause to all our speakers one more time. And now it's time for our Q&A session. So all the questions that you've had, this is the time. I would like to invite our speakers, Dr. Moodley, Panje, Dr. Obua, Dr. Tweezer, and Dr. Jack. Okay, we have our first question. Okay, please.
I have a question for Samir. I think Samir is probably in the best position to judge how the sausages are being made with respect to the data pipeline DSI consortium. Know what's actually happening across the board. What do you think are the strategic actions that we need to be taking, either as individual research hubs or collectively, to address what still needs to happen to achieve the goals that you laid out?
Okay. Scott, I think that's an interesting question. I think projects do have different times and points where they are, but at some point we will need to have an ability to take the analysis pipelines, make that available to the community, as well as the data. I mean, the data might be in your local on-prem facilities, but we know what data sets you have and what data sets are available. There might be open access data sets, but they are available for the community. And if they're under some kind of policies, we do need to know that. From a practical standpoint of view, we do need to get data use ontologies on your data. We do need to figure out where they sit and also what is the access policy. I'm all for open access data because it reduces a lot of the barriers. But I do know in medical and demographic data and health data, they cannot be open access, especially if it's genomic. But also your analytical workflows, those need to be made available to the community. As we're happy to help you open your own DocStore organization account, and you can put them there. One thing I did not mention about DocStore is it's actually discipline agnostic. So you can put in climate change, put in different workflows from different disciplines like environmental science as well. But I do think we have to think about as not just getting your research out there. I mean, that's just one point, your publications, but having your data and your tools and your workflows there for the rest of the community to use once the project is over. Because your project will have a finite lifespan because of the research funding it does have. But all that value that's generated from that research funding, how is it going to translate to the community, and how is it going to be made available to the community? Because once your project ends, what are the assets that continue with your projects? It'll be your analytical tools and it'll be your data sets. And that also speaks a lot to the FAIR principles as well.
Okay, good morning, everyone. Thank you for the presentation. So I have a question for the Dr. Panji, Dr. Jack, and Ubua. This is the same question. So it's about your the platform you presented. I would like to know if these platforms are for only research use, or it is possible to use for academic using, and what are the criteria to use this? And for Dr. Jack specifically, you mentioned Mali in your contacted country. So actually, what is your collaboration with Mali team, and with what institution? And for Professor Celestine, what are the criteria for your PhD recruitment? Thank you.
Who'd like to start?
Okay, I can start quickly. So I'll just talk about the Terra platform. So the Terra platform is free to access and people can access it. You do need to set up a bit of a billing account to actually run some stuff because it is cloud-based and you are going to be charged on that as well. But it is free for accessing and it is able for use for research. And I do know lots of large research groups actually use this, especially single cell analysis as well. So it is free for, you can use it as a researcher and also as an academic. And what we are finding useful with Terra is we're actually using it as a tool for teaching as well. It has a very low barrier because it has a nice user interface as well. So you can take people who are non-computer scientists or non-technical people and actually get them to do analysis and focus on the data analysis rather than trying to set up an environment and getting sysadmin skills and going through a lot of that.
I think there was a question from you. I didn't quite catch it. Something about a collaboration.
Yeah, do you want to restate the question for Dr. Jack?
Yeah, I was talking about collaboration with Mali.
With who? Sorry?
Mali.
Mali. Oh, Mali.
Yeah.
Oh, I don't remember Mali, to be honest. Maybe we can pick it up after the session.
Yeah, it is in your presentation.
Okay, we are looking for data. So we approached some of the data sources or data providers in Mali. Yeah, we can talk about the details later. Thanks. Yeah.
So I would like to know if you have a collaboration with Mali, like a country, and with which institution, because it is mentioned in your presentation that we contacted Mali for collaboration.
So I think that was referring to the data acquisition process. So we're approaching many different data providers from different countries who conducted research in different countries, and may have will be valuable to the project. So it'd be best if we chat afterwards and talk about the particular institutions. Thanks.
Are there other questions?
Yes, you asked the question about the criteria to join the PhD in data science for the research training program in data science for health in Rwanda. And the program is dedicated for Rwandan citizen. And as we want to enhance data science knowledge and skills from master, PhD, and postdoc. So I think we can elaborate more on those criteria. Thank you.
Mine is just a comment to Dr. Lukman Lawal. Thank you for your talk on use of AIs to improve health outcomes. I was just wondering whether you found time to speak to the AU division of health and science policies, so that the leadership of the African continent can get some of the ideas you have in your presentation. Thank you.
Thank you so much. That's a very good comment. And I'm so excited we're in this room to have this conversation. And I think the vehicle of DSI Africa will be very powerful if we can all really be able to agree that's the way to go. Then I think coming out of this conference, part of what would come out is a white paper that we can really be able to level through AU. Individually, I've not had personal conversations with people at the AU, but I think it's something that needs to be had, where we can really push the continent to bring down the silos in a way that could be collaboration across the continent, sharing knowledge, solutions, and data to improve health outcomes for our population. Thank you so much.
Thank you very much. And my question is for Dr. Obua. I really found your talk about sustainability very inspiring. And, you know, the analogy that you draw about you want to skin the animal where it's hunted, because we do want to do the work in Africa. And how do we build political will? How do we get our governments to invest in data science in Africa? I'd love to hear your thoughts on that. Thank you.
Thank you very much for that question. I think one of the biggest drawbacks in any endeavors that we want to do, particularly where it involves research and investment, has been the laid-back approach that has been taken by most of our governments. I think some of the governments have goodwill towards supporting investments, particularly in this case. The economical aspect of it means that governments support researchers to build infrastructure that is needed, to train and retain, because one of the things I talked about in passing was the element of brain drain, that We have people trained, but then they don't find usefulness of their qualifications in Africa. So while we still want to be able to carry out the acquisition of data, storage, and analysis within the African continent or within Africa for that matter, we indeed need to encourage our governments. Unfortunately, in this meeting, maybe it was an oversight to invite some of the government representatives, particularly those either from the ministries of health or science, technology, and development, and so on, to be part and parcel of this meeting so that they hear what the scientists are saying and they hear the cry that is coming out of the scientists, the need for support. It is wonderful that taxpayers in the US give us millions of dollars to carry out these activities, but it will also have look better if our governments gave some counterpart funding to what is coming out of the NIH. So if there is any person who has ears in, perhaps that is the message we want, that we think that African government has money, and it is a question of priority. They probably put priority in other things. The needs are great. I don't want to understate that. The needs within Africa is great, but so is health. So if this is the ways of approaching improvement in health, then we should put our money where our mouths are and encourage our governments to support this initiative. Thank you.
Good morning, everyone. I'm Dr. Lawal, and my question will go to Dr. Lawal as well. And incidentally, we are from the same place in Nigeria, so probably we have to have a family meeting afterwards. And so thank you for that presentation. And my question goes, in the landscape you explained, and I think one of the things that make that landscape also unique is that they want to be convinced before they take the leap. They don't want something just high there in the sky. So have you had any kind of subscription or kind of collaboration with any hospital or any health provider on the continent that can be used as an example of what can happen if we do this? And that would be a way to convince government also to take this forward. Thank you.
So much, my namesake. Thank you so much. Very kind question. And like, yes, truly, I need to have a family meeting. But going back to your question, I think for speaking as an employee of Mayo Clinic platform, I just left Kigali barely 10 days ago. And while coming to Kigali, I also visited 6 other African countries. And what that was for, so I was in Nigeria, Ghana, Senegal for West Africa. Then I also came to Rwanda, Kenya, as well as Uganda, as part of my role, trying to see how we could expand the Mayo Clinic to the continent as part of the global expansion that I'm started with. So yes, we've had initial conversations because what I did in many of these countries were more like stakeholders meetings with people from the different sides of the platform, solution developers, young startups who are working in that space, big companies as well, pharma companies. Then I also spoke with potential data partners, the big hospitals, private and public institutions across some of these countries, as well as the solution users. So some of what we've got is yes, it's encouraging. And these are people that are extremely interested in really coming on the Mayo Clinic platform. But we know it takes quite a while to kind of iron out this requirements that you need as a health institution to benefit from what is on the platform. For example, we need the depth and longitudinal data that's spanning many years. How structured is your data? Is your data cloud ready? And also, how do we leverage the proprietary privacy data pieces that we have at Mayor and others that kind of work with the local data privacy laws. So all these things are things we are looking at, and there are promising companies that have shown interest and that we are currently working with in Kenya, in Nigeria, in Ghana, and I think Rwanda. And hopefully 2024, we should start seeing some of these companies, some of these organizations coming on the Mayor Clean platform that can start being shown as positive use case scenarios for the entire continent. So I'm excited about the potential.
Yeah, morning. Alashla Bimiko from the Institute of Human Virology in Nigeria. Always exciting to hear Professor Modley present. You shared with us really important insights and the complications of the balance we need to have as we work as researchers. And I just wonder, just to hear your insights on how you think we can best take on the ethical and regulatory bodies that we have within the continent that we're working with, maybe DSI Africa to begin with, but in general, how can we have those very tough conversations that would help us to continue our work ethically in our various countries, and also build the capacity within our ethical bodies to be able to look at the complexities of such important work. Thank you.
Okay. Thank you for that question, Alashley. So I think it's a big threat to data sharing is concerns over suboptimal governance. And there is a strong need for ethics guidance as well as legislation throughout the continent. So I think it's an important conversation for all countries to have. There is the issue of national sovereignty. So it's important that it occurs, the conversations occur between scientists from a specific country with their governments who are responsible for these domains in terms of regulation and ethics guidance. I think it's really important as research hubs within the DSI Africa Consortium to have meaningful conversations with national research ethics councils and research ethics committees or IRBs within your various environments to discuss the issues and the challenges on both sides. Because I think if there is an assured governance mechanism and there are good laws in place, good ethics, then scientists are more keen to share data, and data sharing is an important sustainable aspect. I hope that helps, Alash.
Yeah, my question is to Professor Obua. In your response to investment from governments in data science, I think you raised the issue about governments in Africa having a lot of priorities, and possibly that is they have important priorities where they are putting their money to. I agree that the reason why many programs are failing on the continent is that it's not driven by data. It's not informed by data. It's not informed by any evidence. So clearly something has to change. What will it take to continue to convince governments that in fact they need to invest in data infrastructure on the continent?
So thank you for that question. Convincing the African government to interest in building capacity for either data science or for other related infrastructure. I think a colleague said governments sever their independence, and so you can probably talk within your country, and it's a bit difficult to talk across. Although we are trying to see how to bring together the African continent in that aspect. The AU, which a colleague down there referred to, whether our colleague here contacted them on this issue, is one avenue. But the reason why there seems to be no progress when we bring up the issue of this kind of infrastructure is because the governments think they were not part and parcel of the initiation of the thinking around that area. And I think that is where we need to begin to see how do we bring policymakers who represent government into the thinking process before we begin such initiatives. I think when we work through, for some of the countries, I think I would give probably example of Rwanda, although I'm not from Rwanda. I know for a fact that you cannot bring any initiative until it has been given a go-ahead by government. And for some of our countries, we also want to begin to emulate that we involve our ministries, our parent ministries, to give a go-ahead. So often when we make these applications, we get support, letters of support from ministries, from key office, and so on. But when we've now received the award, I think somehow we conveniently forget that the ministry or the office that gave us support letters need to be involved for us to go ahead with some of the development that we are trying to propose. So I think it's incumbent on us, researchers in this room, particularly those from Africa, to look at a different paradigm of how we have been approaching and bringing on board this kind of infrastructural development. We need now to go back and ensure that we engage the ministers. In some aspect, in some of the things we have been doing of late, we have been working with the ministries, with related important offices, and we work with them in order to develop a way forward. And we realize that when that is done, government seems to give it a go ahead and take interest in it, and they want to see that it succeeds. Because then how else do they formulate policies when they have not been involved in the original ideas and development of solutions that will help them to generate this kind of policy? So I think the question you've asked is quite complex, but I think it is possible if we bring these government offices right at the time when we are thinking of this ideas of what we want to do. And then we probably want to ask them, so where do you want to help? Because when we don't ask them what they can do for us, we cannot go back and tell them, you have not done this. We need to be able to engage them in that aspect and task them to make commitments to support the external support that we are getting for this kind of infrastructure. I hope that's helpful.
Thanks a lot to the panel. My name is Claude Kamau from DSI Law, and my question goes to Dr. Moodley. Thanks a lot for analogizing the tragedy of the commons in such a fascinating and interesting way. So sort of one of the inevitable resolutions to this tragedy, according to Hardin, as I've read him, is through the incorporation of the infrastructure of private property. So what he calls, quote unquote, internalizing the externalities, meaning therefore that the problem of addiction is resolved if the individual actors are able to be the ones that are in charge of the costs, and thereby being the only persons that access the benefits. So my question would be, to what extent would this kind of prescription apply to big data? Does that mean that we move towards a regime of sort of internalizing externalities and therefore privatizing access? And as a natural follow-up to that, do you think that we also have the possible threat of tragedy of the anti-commons, whereby multiple can exclude each other from access to the resource, leading to the problem of underuse opposed to the problem of depletion. Thank you.
Very much for your fascinating interpretation of tragedy of the commons. It's a controversial concept, but I think it applies to any situation where we're dealing with a limited or a threatened resource. And in the field of data, I think the term the data commons has often been used, and it's a public resource. So it raises many questions about the dominant role that the private sector is actually playing in big data technology and setting up companies. You know, the equivalent scenario would be looking at the fishing industry and having major corporations, you know, dominating the fishing space to the detriment of local fishermen in villages. So I think within data, there are important conversations to be about the unregulated role to a large extent that is being played by private enterprises and the corporate world in monopolizing the data commons, so to say, and that there is an important role for organizations like DSI Africa to fund and encourage academic players and other public sector players to play a more meaningful role in the data science world. Obviously, there's always space for collaboration and public-private partnerships, but I think both sectors ought to be regulated and as a prophylactic measure to prevent the tragedy of the commons. So I think that's the approach we need to use. Regulation in Africa for Africa, and we need to move away from the copy and paste strategy of taking EU GDPR and developing legislation in African countries. I think that's a cop-out, and I think we need to work harder in Africa to developing our own legislation that is context-specific and relevant to our settings. Thank you.
I have a question for Dr. Jack. My name is Stephen Obaro, and I am a pediatric infectious disease physician. I'm based at the University of Alabama in Birmingham, United States. You give an excellent overview of the potential impact of climate change on health. But I was wondering if you've considered the fact that climate change may actually be impacting indirectly on several factors, such as human behavior, animal behavior, vectors, infectious disease vectors, and trying to perhaps link the data you have to specific disease entities, particularly infectious diseases. And trying to see if you can come up with a model that can predict disease outbreaks. And I'm bringing this up because here in sub-Saharan Africa, we have perennial problems with recurrent outbreaks of meningococcal meningitis. We are having cholera outbreaks at several locations where there haven't been such outbreaks before. So I think looking at specific disease patterns and trying to correlate that with meteorological data would probably be very helpful. Thank you.
Great. Thanks for the question. You're touching on my passion. So how long do I have? Thanks. It's an excellent question. And, obviously there's researchers around the world trying to look at this question of climate and infectious diseases. But I just want to pick up on one aspect of your question is really referring to the complexity of the relationships between climate and disease and health. And I think what we're trying to understand better is the complexity, how all these different factors come together, because often there are many co-founding variables and co-founding factors that have nothing to do with climate. So I work a lot in urban contexts where frequently now we see cholera outbreaks. But obviously it's not just climate, it's not just flooding or lack of water. There are many confounding factors of poverty, water supply, gender issues. It's a really complex space. So I think while there's a lot of disciplinary research looking at the sort of quantitative modeling and prediction of these disease outbreaks, I do want to highlight the need to have a very broad view on these challenges. And again, coming to the multidisciplinary, and I'll even use the word transdisciplinary framing of these questions. Who's involved in the conversations? Where's the understanding coming from? Where's the lived experience of people experiencing these disease outbreaks? Where does that information understanding come into the picture? So short answer is definitely we're doing that. We're just starting another project at the moment on urban climate and health that we're picking up a lot of those. But again, we need to keep the bigger picture as well. So thank you. Love to chat more.
We're coming to the end of our session. I have one last question for the panel, and maybe Kim Andrew might be the best person to, yes.
Yeah, good morning.
Sorry, 1 second.
Okay.
The session is going to end in the next 4 to 5 minutes. So I'm going to let you ask your question and then we'll close it out. I didn't see you, but one more question and then we're closing it out.
Thank you very much. Mine is not just a question, it's a comment. My name is Yashir Mandiati Usman. I work from the perspective of government. I'm from Nigeria. I think I've seen the importance of all the presentations made so far this morning, and it focused on sustainability, involvement of government, the buy-in and everything all around that. One of the things I have taken and I feel is important for me to make contribution for this meeting is how government should be involved in this kind of meeting. If you look around, you will see that you have few of government representatives here, and it is a problem because if you come up with a concept and you want to sell to the government, which they are not part of the system, it becomes a little more difficult. Every government needs to know the importance of data, how they can use it, AI, and how it contributes to what they are doing in time of sustainability. With that, it will give them the sense of trying to sustain, start knowing the importance of to them as a country. Then it goes stronger into the continent where you are talking of AU. The AU makes out of the member state. So if every country understands the importance of what he stands to benefit, it becomes easier for them to be part and move it forward. So my plea to all partners here is a way of seeing how we can bring more of the government into this understanding. Is very important. And I want to thank Info Nigeria in collaboration with IHV. Possible for me to be part of this meeting. I think I have a lot to take from it, and I will look up to see Dr. Luman after this meeting for us to take the discussion further and see how we can incorporate this into the system and for the betterment of Nigeria and the continent at large. Very much.
Thank you. So one last question, and I guess full panel, and then we can close it out and give our speakers a big round of applause. We've gotten very dynamic talks today that there's lots to think about. So my question is, on my comment, and you can tell how you feel about it, is we've spent a lot of money and human labor and resources in collecting this data, especially when it is human data. Do we, and this is also like a ethics and a social responsibility aspect of the data, don't we have a responsibility to make sure that that data is used to the most good as much as possible? Because I sometimes hear this conversation about it's our data, it's our data, it's our data. But if it's a human's data, it's technically not yours. It's that person's data. And I feel you have a responsibility to do as much good with that data as possible. This is me. Now I want to hear your thoughts on how we keep to that mission while still protecting the people and our interests.
So I think that's exactly the point. And this is why we speak about a data commons. It's about moving beyond self-interest. So the extent to which individuals own data is highly questionable. Involving multiple stakeholders is important. Involving the public and community engagement is absolutely critical. And I think every DSI project needs to be held responsible in terms of public engagement. It is a common data source. It's a data pool. There should be an element, a strong element of sharing, and everything should be done to ensure veracity of the data. So high quality data that can be shared and that will be of value to the public. as a common good. That is incredibly important. I think it's important also to be wary in terms of impact on the environment and sustainability, and data centers need to be accountable for their energy footprint, for their consumption, and all this needs to be incorporated into the governance of DSI Africa. Thank you.
Does anybody else have anything else to add? Doesn't look.
Thank you so much. I guess like this is a very important conversation to have, and thank you so much, Prof, for insights you provided regarding the ethics that comes with data handling. And it's always a dilemma to really be able to identify, does the patient own the data, or does the facility own the data, or does the data get passed on to a third party? And it's quite important to really have all this laid out in terms of what laws govern data usage in country. Healthcare data, it's kind of very unique, and we need to really have a very defined laws beyond just the GDPR, like my colleague here said. The GDPR just stands for the Global Data Protection Laws, but how do we domesticate the GDPR in a way that's unique to our specific countries and be able to kind of define who owns the data, at what point does the patient sign off based on what you sign when you come to the hospital, like, yes, the hospital can use my data for good. And I think these are some of the conversations we need to have in our respective countries to really be able to find, I think, for example, I think in Nigeria, they have the NDPR, which is a version of GDPR. How well does the NDPR and the NDPRs for other countries, how well does this the patients, how well does it really help transform healthcare in a way that everybody can benefit from it? So I think it's a great conversation to have of our countries to be sure we have specific laws that protect the patient and also does not limit innovation, because as much as you want to protect the patient, you have to balance that with trying to catch that the continent needs. And thank you so much.
And we've come to the end of our session. Please give our speakers a round of applause. Thank you all so much for it. Yeah, they're waiting for that. Thank you.